Hello, everybody. Once again, I am here with you for the new session, and we are already at the stage of the last unit, that is free electron theory of metals is to be there. In previous session, we have seen what is the outstanding properties of the metals are to be there, and what is the Drude Lorentz theory is to be there. Now, what exactly electrical conductivity? Then afterwards thermal conductivity, and using this electrical and thermal conductivity, what is Weidmann French relation we will see today. Now first of all we start with the electrical conductivity. Excuse me. Now for in general case we are already aware, in the first year we have seen what is mean by to be as an excuse me, what is mean by to be as a mean free path, that we have seen in detail. Now here using this factor, that is relationship for the lambda t and u, that is the time taken between the two successive collisions, that is nothing but to be tau, and velocity among that is to be u, and lambda is nothing but to be a mean free path, that is the distance lambda meanings to be, and u is nothing but to be velocity, and t is to be as an time. Now free time in say in such manner we can say, if we replace this, you will see velocity is distance upon time, that will also occur, and this is what the relation it is found, tau is equal to lambda by u is to be there. Now considering this factor, if suppose the electric field is going to be applied, then in that case what happens, for as far as E is supposed to be the electric field is going to be applied, and here it is to be the relationship, it is E is nothing but to be electric field applied. Now in this case the equation of the motion of the electron is given by m into d2x by dt square is equal to minus E into capital E. Capital E is nothing but to be electric field applied, and minus E with the electron of charge that is to be there, and either this relationship m जर इकडे घेतला तर इथं डिवाइड मध्ये जाईल, आणि हेच नवीन रिलेशन बदल d2x by dt square is equal to minus of E into capital E by small m is to be there. This is what the equation of motion of the electron. Moving forward, this relationship can be used for integration, and integrating this we have the relationship that is to be basically as it will give us x dot is equal to minus of E into capital E upon m t plus c is to be there. But when x is going when t is going to be 0, time is going to be 0, x is also going to be 0. So in that case, if you look at this case, it is 0, and this will be coming to be as an, this part is also to be 0, then c is definitely becomes to be as a 0. That's what the case where the c will become to be 0 when t is equal to 0 and x is becoming to be as a 0. Now in this the dx by dt is equal to nothing but to be our x dot, and it is also given in the fashion is equal to minus E into E t upon m is to be there. Average velocity between the two collision is nothing but to be given as a, this is average means bar is to be there, and that's why x dot bar is equal to 1 by tau integration 0 to tau, and in this case the 0 to tau integration minus E capital E upon m into t dt is equal to, we have the relationship that is minus of 1 by tau small e into capital E upon m into tau square by 2 is to be there. This is what the integration part is to be there. Again we can simplify this and we can get the relationship as like this tau, and the square is going to be the cancelling, and the remaining average velocity between the two collisions is nothing but to be given with this relationship, and that is uh, x dot bar is equal to minus e capital E by m into tau by 2 is to be there. This is equation number 2.2, or the second we can say. Using this relationship, if I be the current density, then in that case, and n be the number of electrons per unit volume. So in this case, I be the current density, and n be the number of electrons per unit volume. In that case, I is nothing but to be given with this relationship, that is I is equal to minus n e x dot is to be there. आता n as it is, e as it is, पण x dot ची व्हॅल्यू आपल्याला माहिती आहे e इंटू कॅपिटल ई बाय एम टॉ बाय 2 इज टू बी देर. हे इंटू जर ह्याला केलं तर ई इंटू ई ई स्क्वेअर होईल, आणि म्हणून नवीन रिलेशन जे काय मिळणार आहे दॅट इज 1/2 एन ई स्क्वेअर स्मॉल ई स्क्वेअर इंटू कॅपिटल ई बाय एम इंटू ह्या टॉच्या ऐवजी पहिलं जे रिलेशन होतं टॉ इज इक्वल टू लॅम्बडा बाय यू हे इथं रिप्लेस केलं, आणि म्हणून नवीन रिलेशन जे मिळालं ते दिस मच ऑफ अमाउंट. नाउ सपोज this multiplying and dividing throughout equation by u, right hand side, I is equal to then half n e, this is what the new case, half n small e square into capital E by m into here lambda by u into u by u, u नी मल्टिप्लाय आणि डिवाइड केलं तर इथं काय होईल m इंटू यू स्क्वेअर होईल या ठिकाणी. आणि या केसमध्ये इन जनरल आपल्याला जी माहिती आहे कायनेटिक एनर्जी पार्ट इट इज हाफ एम यू स्क्वेअर इज इक्वल टू 3/2 kT is to be there. As we know that kinetic energy in that case half mv square आपण म्हणतो, that is half mu square is equal to 3/2 kT. मग याला जर हा जर 2 जर इकडं घेतला तर हा n2 होईल आणि 2/2 कॅन्सल होईल, म्हणजेच mu स्क्वेअर इज इक्वल टू मी काय लिहू शकतो 3 kT, म्हणून mu इज इक्वल टू 3 kT. आता mu स्क्वेअर जो आहे तो इथं आहे, म्हणजे या ठिकाणी मला mu स्क्वेअरच्या ऐवजी 3 kT रिप्लेस करता येते, अँड दॅट्स व्हाय आय कॅन राईट द रिलेशनशिप ॲज लाईक दिस, अँड that will give us nothing but to be new relation substituting the values of mu as I told you, that is to be as an here half, the new relation will be I is equal to half n e square capital E lambda u divided by 3 kT, इथं 3 kT आलं, that means to be as an इथं पुन्हा आणखीन जर समजा ह्याला सिम्प्लिफाय जर करतो म्हणलं 3 into 2 that is 6, आणि म्हणून नवीन रिलेशन जे आहे I is equal to n small e square capital E lambda u divided by 6 kT. So this is what the, again we are aware about that it is nothing but to be I is equal to sigma E, and that's why here it is to be as an sigma is nothing but to be E जर बाजूला केला तर sigma is nothing but to be your electrical conductivity, and it is nothing but to be given as a n small e square lambda u divided by 6 kT is to be there. So this is what the relationship for the your electrical conductivity, and it is very easy to get the 5 marks for the electrical conductivity. Thanks for joining this session. The next part, thermal conductivity, we will see in the next unit. Till then, be at home and be safe.